Hey everyone, this lesson is on factoring trinomials by grouping. Trinomials means there's three terms. There are other methods for factoring trinomials. This is just one of them. This is called the grouping method. Some people might just put in the numbers to make it work. That's great. This is also called the AC method. Some people like to make an X and do that. Some people use a box. There's different ways of organizing. So if you've learned another method, that's totally fine. This is just one method for factoring trinomials, and this is grouping. Again, it's also called the AC method. Okay, at any time you could always pause so you could write down the notes. But here's our first step. Multiply the first and last number, a times c. So we're considering that trinomial that's written above, ax squared plus bx plus c. So we're multiplying a times c, that's why it's called the AC method. And don't forget to keep the signs. So if one's positive and one's negative, then your answer will be negative when you multiply. If they're both positive, then it'll be positive. Okay, then we're going to list all the factors of the result. Don't worry about the sign at this point, but we're just going to list all the factors. Okay, this is where it gets a little complicated. We're going to look at the last sign of the last term. If it's negative, find the pair which will subtract to equal the middle number. And if it's positive, find the pair which will add to equal the middle number. Attach signs to the pair such that the product equals the number from step 1 and the sum of the numbers equals the coefficient of the middle term. I know it's getting complicated, right? When we see an example, it'll get a little bit more clear. Then what we're going to do is we're going to separate the middle term into two terms with the pair that was found. And we're going to use the attached signs so the value is not changed. So we're just going to separate our middle term into two terms. And the main reason for that is so that we could factor by grouping. The last step is to check. You don't always have to do it, but if you want to make sure your answer is correct, then it's always a good idea to check your answer by multiplying or by the FOIL method. Okay, so make sure you have all those notes written down. A note card might be handy for this so that you can refer back to it. Maybe a big note card, right? Like a 5x7. Okay, here's our first problem. 2x squared minus 5x minus 12. Now in these first few examples, these trinomials are already written in descending order, and there is no GCF. In later examples, we'll do some problems where they're not in order, or there is a GCF. Okay, our first step is to multiply the first number and the last number. So a times c. So our a is 2, and our c is negative 12. That gives us negative 24. All right, second step. List the factors. So that means anything that multiplies to be 24. Try to write it in order, starting with 1. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, here's step 3. Now, we're looking at the last term. It's negative. That means we want to find the pair that subtracts to equal the middle number. Our middle number is 5. So which of the pairs will subtract to equal 5? Let's see, the first pair is 24 and 1. That subtracts to be 23. The second pair, 12 and 2, that subtracts to be 10. 8 and 3, that's it. That one subtracts to be 5. 4 and 6 subtracts to be 2. Okay, so we know what pair we're going to use. If the last sign was a plus, then we would want to find the pair that adds to equal 5. And there is no pair that adds to equal 5. So we're going to use a 3 and 8. Let's circle it. Now, we want to put signs so that it equals -5. So what signs can we put in front of the 3 and 8 that will equal -5? The signs have to be different, right? They have to be different because it also multiplies to be -24. So the only way those two numbers multiply to be equal to -24 is one has to be positive and one has to be negative. So which one would be negative and which one would be positive? Well, the 8 would be negative and the 3 would be positive. Positive 3 and -8 has a sum of -5. So that's the pair we're going to use, and we're going to separate the -5x into two terms. It doesn't matter the order. If you want to put the -8 first, you can, or the 3 first, you can. I'm just going to go in order from smallest to largest. So 2x squared plus 3x. So remember to attach the variable that's in the original trinomial. It's an x. So it's plus 3x minus 8x, and then the last term is minus 12. Now we're going to factor by grouping. So look at the first pair and the second pair. What's the GCF for the first pair? Yeah, that's right, x. And what do we get? 2x plus 3. What's the GCF for the second pair? 8 and 12, the GCF would be 4, but the first term is negative, so it'll be -4. And then divide both of them by -4, that'll give you 2x plus 3. The binomial, that's our GCF now, is 2x plus 3, so that'll be written first. And then x minus 4 will be second. Again, the order doesn't matter. If you wanted to write the x minus 4 first and then the 2x plus 3 second, that would be fine because multiplication is commutative. You could check the answer by multiplying. So FOIL, let's see, 2x squared minus 8x plus 3x minus 12. Add your two middle terms, and it should give you the original trinomial. Okay, here's our next example. Again, you might want to try to pause the video and give it a shot. All right, multiply the first number and the last number. -60. List all your factors. This one has a lot, right? 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. We're really just looking for one pair. If you don't write them all down, it's not a big deal, but I find that if you write them all down, you're definitely going to find the right pair. Okay. So which one will subtract to be the middle number? Our last sign's a negative, right? So we're going to find the pair that subtracts to equal the middle number. 4 and 15? Yeah, that's it. 15 minus 4 is 11. Now we're going to figure out our signs. We want to get a -11, so that means the 15 has to be negative and the 4 has to be positive. Okay, now we'll separate the negative 11x into two terms. Bring down the 10x squared. Then it'll be plus 4x minus 15x minus 6. Now we can vector by grouping. GCF for the first pair is 2x. GCF for the second pair is negative 3. Now our common binomial factor is 5x plus 2. So that'll go first, and then the 2x minus 3 will be second. You should check, but I'm not going to show it at this point. You know how to FOIL that. So let's go on to the next one. All right, let's multiply the first number and the last number, A and C. That'll be 12. Now we're going to list the factors. One times 12, 2 times 6, 3 times 4. Now the last term, the 4, is positive, right? That means we want to find the pair that adds to equal the middle number. Which of these pairs will add to be 13? Yeah, that's right, it's the 1 and 12. Now we want to attach the signs so that it equals negative 13. What will the signs be? That's right, negative 1 and negative 12. Now we could separate our middle term into two terms using the negative 1 and negative 12. Don't forget to attach the variable. The order doesn't matter. If you have the 12x first, that's fine. It'll look a little different, but the end result will be the same. All right, now we can factor by grouping. What's the GCF for the first term? Sorry, what's the GCF for the first pair? That'll be x. And then what's the GCF for the second pair? For 12 and 4, it'll be 4, and since the first term is negative, it'll be negative 4. And then our binomial is the same, 3x minus 1. Again, you should check by multiplying. I'm not going to show it here, but you could easily show that when you FOIL, you'll get the original trinomial. All right, here's our next example. 4x squared minus 12x plus 9. First step, multiply A and C. That's 4 times 9. 36. Now I'm going to list all the factors. Kind of a lot, right? Well, the last sign is positive, so we're looking for the pair that adds to be the middle number, which is a 12. So once you find the pair that adds to be 12, then you're done with that step. You don't have to list all the factors. All right, which pair will add to be 12? Yeah, the 6 and 6. So that's the pair we're going to use. Now we want to attach this sign so that it equals negative 12. What signs must they be so that they add to equal negative 12. Yeah, that's right, both negatives. Negative 6 and negative 6. So now we're going to separate the middle term into two terms. Don't forget to attach the variable. And now we can factor by grouping. GCF for the first pair, 2x. That'll give us 2x minus 3 inside the parentheses. GCF for the second pair, 3, but the first term is negative, so it'll be negative 3. And then the result will be also 2x minus 3. So now the common binomial factor is 2x minus 3. It's shown in blue here. And then what's left over is the other 2x minus 3, which is shown in red. Notice that these two binomials are exactly the same. So another way of writing it is 2x minus 3 squared. There's a special name for this trinomial. It's called a perfect square trinomial. We're going to talk about this topic in the next video. So we'll keep this problem in mind. Whenever the binomial is written twice, and then you can write it as a square, it's called a perfect square trinomial. Okay, don't worry too much about it right now, but we're going to do that in the next lesson. Again, you could check by multiplying. I didn't show it, but you can FOIL and get the original trinomial. All right, here's our next problem. Y squared minus 13y minus 30. Multiply a and c. Well, what's our a? That's the number that's in front of the variable squared. I know all the other previous examples I used x, but this one's a y. Same thing, just a different letter. So what's the number in front of the y squared? It's just 1, right? So 1 times negative 30 is negative 30. List the factors. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now, the last term is negative. So we want to find a pair that subtracts to be 13. So you really need to know these rules. This one's it's a good problem because a lot of people will make a mistake and use the wrong pair. Which of those pairs will subtract to be 13? Right, the 2 and 15. Some people will use the 3 and 10 by mistake, but that subtracts to be 7. Now 3 and 10 will add to be 13, but we don't want those two numbers to add to be the given number. We want them to subtract. So that's why we need to use the 2 and 15. Now we can attach our signs. Again, we want a negative 13, so what should the signs be? Positive 2, negative 15. Separate our middle term into two terms. Now we can factor by grouping. GCF for the first pair is just y. GCF for the second pair, it's not 5. If you factor out a 5, you're going to notice that the binomials won't be the same. That'll tell you like, oh, it's not the right GCF. It's a negative 15. 15 goes into 15 and 30. Now our binomials match, so the answer will be y plus 2 times y minus 15. Okay, this one's still a trinomial. It's a little bit different because we have variables on the last term as well. It's a variable squared. So in the first term, it's x squared. The second term, it's xy. And the last term, it's y squared. Keep in mind, it can be done with other variables. It can be done with an a squared and a b squared. So we're looking at trinomials of this form. We're still going to follow the same steps. Multiply the first number and the last number. That'll be 18. So it's just 18. There's not a variable in this part of the problem. Just 18. Now we're going to list the factors. 1 and 18, 2 and 9, 3 and 6. It's positive, right? The 6y squared is positive. So we want to find the pair that adds to equal the middle number. Which of these pairs will add to be 11? You're right, the 2 and 9. Now we want to attach the signs. So what do the signs have to be so that 2 and 9 equals positive 11? Right, both positive. Now we could separate the middle term into two terms. Our middle term is an xy, so that just means that both 2 and 9 are going to have a variable part that's xy. So 3x squared plus 2xy plus 9xy plus 6y squared. Now we can factor by grouping. What can we factor from the first pair? Just an x. That'll give us a 3x plus 2y inside the parentheses. How about our second pair? A 3 and a y. So 3y. What will that give us? The same thing, 3x plus 2y. That looks good, right? Our binomials match. If they don't match, we've messed up. We've got to figure it out. Or maybe it just doesn't factor. All right, now we can write the answer. 3x plus 2y times x plus 3y. All right. Here are our general steps for factoring trinomials by grouping. Number one, well, these are actually just general. Number one is a general step for any factoring problem. We have to arrange it in descending order. So here we have to arrange the trinomial in descending order. Step two is to factor out the GCF. If the first term is negative, factor out the negative along with the GCF. So if the first term is negative, then the GCF is negative. And then we're going to factor the trinomial if possible. Don't forget to write the GCF in front of this factorization. Okay, here's our first example. Huge numbers, right? 55, 20, and 30. Okay, don't panic yet. We got to follow our steps. What's our first step? Number one was, is it in order? Heck no, right? It's not in order, so we got to put it in order. So which term would go first? Right, the 30x squared. So 30x squared, the 55x is positive because there's not a sign in front of it, and the 20 is our constant, which is last. Second step, GCF. Let's see, they don't have an x in common, but there is a 5 in common. So we're going to factor out the 5. Divide each term by 5, and the result is written inside the parentheses. 6x squared plus 11x plus 4. Now we're going to factor the trinomial. So I just rewrote it over again, 6x squared plus 11x plus 4. And keep that 5 in mind. We're going to bring that down in our final answer, but now we just do what we were doing in the last examples. Multiply the first number and the last number, which is 24. List the factors. 1 times 24, 2 times 12, 3 times 8, 4 times 6. The last term is positive, right? The 4 is positive, so we want to find the pair that adds to equal 11. Which pair will add to equal 11? Right, the 3 and 8. Now we're going to attach the signs. So what signs must they be so that the 3 and 8 add to equal positive 11? Both positive. Separate our middle term into two terms using the 3 and 8. Don't forget to attach the variable. Now we can factor by grouping. 3x for the first pair, and the GCF for the second pair is 4. Our two binomials match. So we're all done. Oh, but don't forget to bring down the 5. Yeah, a lot of people will forget to bring down the GCF once they factor the trinomial. If you're inserting your answer online, it would be wrong without the 5. If it's being graded by hand, you would lose some points because you forgot to bring down the GCF. So always keep in mind, don't forget to bring down that GCF. You can always check your answer by multiplying. If you were to multiply that all out, first multiply the two binomials, so FOIL, and then whatever answer you get, multiply the 5 all the way through. And you should get the original trinomial. Alright, here's another one. What's our first step? Right, put it in order. Is there a GCF? Well, there's no GCF except for 1, and since the first term is negative, we have to factor out a negative 1. So that first term of the trinomial needs to always be positive. So we're going to factor out a negative 1 from that trinomial. Okay, so what does that do to all the signs? They all get changed, right? Now we're going to factor that trinomial. Right. Multiply the a and c, so that's 1 times negative 40. List all your factors. Which is the pair that will subtract to be 3. Right? The last term is negative, so we want the pair that subtracts to be 3. That would be 5 and 8. And what signs will they be so that its sum is negative 3, positive 5, and negative 8? Separate the middle term into two terms. Now we can factor by grouping. GCF for the first pair is x. GCF for the second pair is -8. Our binomials match. X plus 5 times x minus 8. And then don't forget to bring down that negative. If you want to put the 1, you can. Normally we don't write the 1, we just leave the negative sign, so negative. And then in parentheses x plus 5 and x minus 8. Alright, we got a couple more. Not all trinomials can be factored. If this is the case, the answer is to be written as not factorable. The word prime is also acceptable. Alright, so here's the next problem, number 9. X squared plus 8x minus 16. Multiply the a and c, the 1 times -16. List all the factors. Which of these pairs will subtract to be 8? The last time's negative, right? So we want to find the pair that subtracts to be 8. There is not one. That means it's not factorable. That's what we put for an answer. Not factorable. Okay, let's look at the product of these two binomials. X squared minus 3 times x squared plus 5. If you notice, the answer, when you multiply, comes out to x to the 4th plus 2x squared minus 15. Factoring is going in reverse from multiplying. So we're going to have problems like x to the 4th plus 2x squared minus 15, and we're going to factor that. Notice that in the parentheses, the first two terms of each parentheses is x squared in the first positions of each binomial. Alright, so if we have a trinomial in this form, ax to the 4th plus bx squared plus c, it can be factored with x squared in the first positions of the parentheses. And we could still use the factoring by grouping technique for these trinomials. When we split the middle term, the variable part must remain the same, x squared. It's going to be half, it must be half of whatever the first term was. Right, so in these problems, the first term is x to the 4th, right? The second term has to be x squared. If the first term was x to the 10th, the second term would have to be x to the 5th. Alright, here we go. 2x to the 4th minus 13x squared plus 15. Same process. Multiply the a and c. That'll be 30. Again, we're just multiplying the first number that's in front of the x to the 4th and the last number. Now we're going to list our factors. One and 30, 2 and 15, 3 and 10, 5 and 6. We've used these numbers before, right? Now, since the last term is positive, we want to find the pair that adds to equal the middle number. Which of these pairs will add to equal 13? That's right, the 3 and 10. The last time we had this, we had a 30, we were looking for the pair that subtracts to be 13. This time we're looking for the pair that adds to be 13. So that'll be the 3 and 10. And then we want to attach our signs. So what signs do they have to be to equal negative 13? Both negative. Now we're going to separate the middle term into two terms. Don't forget to attach the variable, which is x squared. Now we can factor by grouping. What's our GCF for the first pair? That's right, x squared. So if you factor out an x squared, that's going to give you 2x squared minus 3. Now for the second pair, what's our GCF? Negative 5. That'll also give us 2x squared minus 3. There's our final answer, 2x squared minus 3 times x squared minus 5. You could also check it by multiplying if you want. It should work. All right, I'll see you here for the next video.